All right. Another beautiful Friday for us today. And I am so excited to be here live and sharing with you the wonderful insights that I got this week. I had the distinct privilege this week of being able to attend NVIDIA's GTC conference. Now, admittedly, it was remotely, so I was seated right here learning everything I can about the latest in AI from the likes of NVIDIA. And it was a tremendous event this year. I particularly enjoyed not only the keynote that we're going to talk about in detail here, but they had over 1,000 different opportunities to learn and understand not only the NVIDIA ecosystem, but a lot of the more complex topics around artificial intelligence, digital twins, simulation, robotics, all kinds of wonderful and amazing things that NVIDIA has been working on. And boy, do we ever live in amazing times. So today's broadcast, basically, we're going to cover NVIDIA GTC. And I'm really excited to share what I've learned with you. And, really the biggest problem that we're going to have today is that there's just not enough time to go over everything that I want to talk about. I'm really impressed. I've come away very impressed this week with the overall vision that NVIDIA seems to have for the future. I'll admit there's a lot of detail here that I didn't understand or see before, and I think it's a lot more clear to me now. But we also have so many advances in the AI space that are being made, both from a computational standpoint and from a technology standpoint with models and the like. So I'm just going to dive in. We're going to talk through a couple of slides, and then I'm going to take you into sort of the supercut that CNET built of the keynote, because there's a lot to cover and I've got to start somewhere. So NVIDIA Supercut is a fine place to start with that. But, before we jump into that live, I want to take some pieces out of the keynote and share with you some of my thoughts. They're not necessarily the most complete thoughts, but I'm really left with some pretty interesting impressions about what I saw this week. Now, even before we talk about the keynote, you can't miss the conversation around NVIDIA on Wall Street. There's been a lot of discussion around AI. And listen, right now, NVIDIA is the AI compute company because they are providing all of the big AI companies with the compute that they need to build the models and to do the inferencing, the calculation, the execution of the chatbots and other programs that are being built on this generative AI technology and other AI models that are around. But let's be honest, right? We're here to talk about generative AI to a larger degree because that is the major feature set. But NVIDIA, over the last couple of years, has absolutely gone parabolic. Their growth in the stock just in 2024 has been absolutely incredible, rising to new heights like never before. I think the stock is closing over $900 a share just today. And so, when we talk about, I'm having a little live broadcast, ladies and gentlemen, live broadcast here. My slides are not working right, so rather than bore you with a blank page, let me preface the keynote shortcut that CNET gave, and then I'll just stop the video at the right moment, and we'll talk in more detail about what is being said in the presentation. I think Jensen did a great job of running the keynote, and let's just watch a few minutes of it, and I'll stop and So here you have a great shot of Jensen showing off the new processor. What's interesting about what he's sharing here is just the raw die size in terms of the raw compute compatibility capability that's in the chip, you see that the number of transistors is growing on a chip that is the same size. And when you see a substantially larger chip, that means not only are they packing more transistors into that same space, but they're actually growing the space that they need. So it's not simply they're just adding more processors. What we're seeing is that they're adding additional capability. So what they've got embedded in this chip isn't just more compute. They're doing more things with the compute that is there as well. So when we look at the size of this raw die, we're seeing not just a doubling or a typical growth of raw compute, but also enhanced capability because they've added more to what the chip can actually do.
It's okay, Hopper. 208 billion transistors, and so you could see, I can see there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second, so that these two sides of the Blackwell chip have no clue which side they're on. There's no.
And so the key here that I think might be missed by somebody that doesn't understand the core chip architectures and the way that these things are built, what we're witnessing with Blackwell is they're fundamentally changing the core architecture, not just of the platform in terms of the way the different parts of the platform come together, but the orchestration of the chip's compute capability. What we're seeing across the board, whether it's NVIDIA or Apple or Intel, is the memory is being placed more adjacent to the raw compute capacity. And in the case of these GPUs, the reorganization of the architecture means that no longer do you have the delay or the wait between the calculation and where that information is stored. And that's really critical. And we're going to see this come back again in a minute when we dive into the architecture.
Issues, no cache issues. It's just one giant chip. And it goes into two types of systems. The first one is form fit function compatible to Hopper. And so you slide on Hopper and you push in Blackwell. That's the reason why.
And this is really important too, because spending so much time in the data center for me over the last 20 years, the footprint in the data center is absolutely an essential part of the conversation. What they're able to do is reuse some of the orchestration and footprint that's already been built to support the use of these GPUs. So if you have racks and racks of the H100, which is the best today before Blackwell came out, it's what everyone is running today if they have the latest and greatest in GPU capabilities. They're able to slide out a tray of one architecture and slide in a tray of another because there's a lot of compatibility in the system. And that's essential for a company like NVIDIA because they've been selling these GPUs like nobody's business. They have built out so many of these, and the partners that they're working with have requirements that have to be met. You can't just do anything that you want when you're a primary vendor like NVIDIA because they need to partner to bring these capabilities to market. And so this is a big selling point. If you're a data center person, you understand what the implications of this capability are. Now, there are limitations to what you can do with this, but this is going to allow NVIDIA to deploy this capability more rapidly to many of the cloud providers that they're already working with.
One of the challenges of ramping is going to be so efficient. There are installations of Hoppers all over the world, and they could be the same infrastructure, same design, the power, the electricity, the thermals, the software, identical, push it right back. And so this is a Hopper version for the current HGX configuration. And this is what the second Hopper looks like this. Now this is a prototype board. This is a fully functioning board, and I'll just be careful here. This right here is, I don't know, $10 billion.
Now, what's funny about this is Jensen has a captive audience, right? There are literally thousands of people in the room, and most of them are geeks like me that spend their time learning about AI, working on compute, doing really interesting projects with software and hardware. And what's funny about this is that if you've ever worked in the technology space, you understand the level of investment that's required to bring some of these things to fruition. When you design the first prototype, it really does cost that much because all of the research and engineering and time and effort goes into making the one. In fact, the reality of all of these companies that are in the semiconductor business in particular spend all of their money on building the prototype, and then they don't really make any money until they're able to create the production line and scale it up. So the truth of the matter is, for them to make and manufacture the parts, it's orders of magnitude less expensive for them to actually make it in raw materials. But it's not possible to make that without spending all of the money, in this case, the $10 million to build the prototype, the V1, the architecture and the layout and all of the design that's necessary to manufacture this at scale for the rest of us to consume.
The second one's 5. It gets cheaper after that. So any customers in the audience, it's okay. The Grace CPU has a super fast chip-to-chip link. What's amazing is this computer is the first of its kind where this much computation, first of all, fits into this small of a place. Second, it's memory coherent. They feel like they're just one big happy family working on one application together. We created a processor for the generative AI era. And one of the most important parts of it is content token generation. We call it, this format is FP4. The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip. This chip is just an incredible chip. We call it the NVLink switch.
Now, this is the part of the keynote that my jaw dropped open. The level of work that had to have gone into building this capability, I think, is going to be the underpinnings of the major advancement that we've seen with the development of Blackwell. So what you see on the screen here is, and Jensen's going to talk about it in more detail, but I really think he didn't spend enough time on this, if I'm totally honest. The ability for the NVLink to connect at speed across all of the processors that are in the full build out of the compute is absolutely incredible. So often has the network been the bottleneck in these large workloads. With this advent of the improved NVLink, they're operating at a speed that we've never seen in a typical data center setup. In fact, I looked it up prior to the discussion today. The fastest available network prior to this announcement of NVLink that had been tested, or somebody had actually worked with or demonstrated in a lab, was 900 gigabit. And this is 1.8 terabit per second. So they've doubled what was built prior to this with their proprietary NVLink capability. Now, it's full duplex. It does all of the interconnectivity for the processors. And as Jensen talks through it in the keynote, he explains that not only does it do the connection, it's able to participate in the computation as well.
It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second, and it has computation in it, as I mentioned. What is this chip for? If we were to build such a chip, we can have every single GPU talk to every other GPU at full speed at the same time. You can build a system that looks like this.
I particularly enjoy the golf clap that he gets. in the announcement of this brand new GB200 platform. This is the new DGX, and this is going to essentially enable us to scale up generative AI capabilities around the world in an incredible way. And the numbers that you see on the screen, he's going to go through in a little bit more detail, but everything here is multiples of multiples in terms of what has been possible through today. So we're not talking about a minor incremental upgrade. We're talking about leaps and bounds ahead of what was possible before. And my observation of this is that NVIDIA has basically taken the understanding that they have for what generative AI requires, and they've not only scaled it up in terms of a generation, but they've scaled it up in terms of its capability. In other words, they're combining advantageous advancements in the chip processing and the software that is behind it.
Now this system is kind of insane. This is one DGX. This is what a DGX looks like now. Just so you know, there are only a couple, 2, 3 exaflops machines on the planet as we speak. And so this is an exaflops AI system in one single rack. I want to thank some partners that are joining us in this. AWS is gearing up for Blackwell. They're going to build the first GPU with secure AI. They're building out a 222 exaflops system. We're CUDA accelerating SageMaker AI. We're CUDA accelerating Bedrock AI. Amazon Robotics is working with us using NVIDIA Omniverse and Isaac Sim. AWS Health has NVIDIA Health integrated into it. So AWS has really leaned into accelerated computing. Google is gearing up for Blackwell. GCP already has A100s, H100s, T4s, L4s, a whole fleet of NVIDIA CUDA GPUs. And they recently announced the Gemma model that runs across all of it. We're working to optimize and accelerate every aspect of GCP. We're accelerating Dataproc, which for data processing, their data processing engine, JAX, XLA, Vertex AI, and Mujoko for robotics. So we're working with Google and GCP across a whole bunch of initiatives. Oracle is gearing up for Blackwell. Oracle is a great partner of ours for NVIDIA DGX Cloud, and we're also working together to accelerate something that's really important to a lot of companies, Oracle database. Microsoft is accelerating, and Microsoft is gearing up for Blackwell. Microsoft and NVIDIA has a wide-ranging partnership. We're accelerating, CUDA accelerating all kinds of services when you chat, obviously, and AI services that are in Microsoft Azure. It's very, very likely NVIDIA's in the back doing the inference and the token generation. They built the largest NVIDIA InfiniBand supercomputer, basically a digital twin of ours or a physical twin of ours. We're bringing the NVIDIA ecosystem to Azure, NVIDIA DGX Cloud to Azure. NVIDIA Omniverse is now hosted in Azure. NVIDIA Healthcare is in Azure. And all of it is deeply integrated and deeply connected with Microsoft Fabric. A NIM, it's a pre-trained model, so it's pretty clever.
Okay, so let me stop there before we get into the NIMs. So let's just go back to what he's talking about in terms of the partners. I think the key with the partners discussion is
a NIM.
Essentially that all of the major cloud providers are getting this capability to work with this Blackwell platform. They've made the preparation, they've put in the work to build out the capability across all of the platforms. So no matter what cloud provider you are working with, whether that's Oracle or Microsoft or Google, you're going to have this capability built in, and you're going to be able to scale up and use it almost immediately. Now, before we dive into the MIMs, I want to talk a little bit about what was really interesting to me with this instance of GTC is the amount of effort and thought that NVIDIA put into not only the hardware platform and the underpinnings that everyone is going to be building upon, but also the way that we can deploy and use this technology across the board. And as Jensen talks about it, he discovers to us this concept of an AI factory, which is not a new concept in the industry, but I think the way that he's thinking about it is a little bit differently than what I've heard in the past.
It's a pre-trained model, so it's pretty clever. And it is packaged and optimized to run across NVIDIA's installed base, which is very, very large. What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. They could be open source, they could be from one of our partners, it could be created by us, like NVIDIA Moment. It is packaged up with all of its dependencies. So CUDA, the right version, cuDNN, the right version, TensorRT, LLM, distributing across the multiple GPUs, Triton Inference Server, all completely packaged together. It's
So what you see here is that NVIDIA is building on top of the modern infrastructure practices that are widespread today. If you're in an enterprise environment, you're virtually guaranteed to be running Kubernetes somewhere inside of the organization. Whether you're running it full stack yourself or leveraging a platform provided by a cloud provider, you have the core capability of bringing things in to Kubernetes and running that at scale for your organization. What NVIDIA's done with this NIM platform is they've taken that capability and they've more created a specification that you can leverage that includes all of the necessary bits in that package. So instead of having to go out and pull together all of the details for the encoding, the decoding, the memory optimization, the GPU, and the tuning, all of those things that are typical and needed for a generative AI workload, they're including that in this NIM setup. So they're making it a much more industrialized process and taking some of the toil out of working together and understanding all of this. And this is really based upon the concept of containers that we've been looking at and working on in the infrastructure side of things for a number of years. What I observe happening with the combination of Blackwell and the NIM capability that NVIDIA is bringing forward here is NVIDIA has essentially removed the need for all of the existing compute that an organization might be using today. What I see happening here is that they're able to provide an execution platform that is entirely NVIDIA's BOM. They've taken their own set of processors, they have their own network, they have their own compute stack, and they're limiting the amount of need to go back to a traditional CPU for getting work done on the platform. And they've really abstracted that away. And so what we're going to see happen, especially for companies that are adopting this NIM platform, is they will no longer have a core concern around building out the compute behind things. If they're leveraging this NIM platform, that will be less of a problem. I kind of see this as a next gen level of virtualization because they've abstracted a lot of the complexity out and created a standard to access those CUDA GPUs with a predefined set of practices and standards.
optimized depending on whether you have a single GPU, multi-GPU, or multi-node of GPUs. It's optimized for that. And it's connected up with APIs that are simple to use. These packages, incredible bodies of software, will be optimized and packaged, and we'll put it on a website. And you can download it. You could take it with you. You could run it in any cloud. You could run it in your own data center. You can run in workstations if it fit. And all you have to do is come to ai.nvidia.com. We call it NVIDIA Inference Microservice, but inside the company, we all call it NIMS. We have a service called NeMo Microservice that helps you curate the data, preparing the data so that you could teach this, onboard this AI. You fine-tune them, and then you guardrail it. You can even evaluate the answer, evaluate its performance against other examples. And so we are effective.
So this architecture is actually really important to talk about, and I want to take a few minutes to go through this. What you see on the screen here with what they've built out across their NeMo microservice is a series of capabilities that sort of creates the industrial iteration of the process. We look back in history, and what Henry Ford is known for, right, was building out the production line, right, industrializing the manufacture of a vehicle. Now, regardless of how you feel about Henry Ford, no one can doubt that his major contribution was this idea of a regimented production line where you could ramp up and take care of a single task and build that thing through a factory. And this is where the core analogy of the AI factory comes from when Jensen talks about it. But what we have here on the left side of the screen is the foundation model. They're building out that capability. Then you're stacking on top of that foundation model, which, let's just be honest, the foundation model is built on something like a Blackwell because they've built that platform to build foundation models. That's the likes of GPT-4, Claude 3 Opus, Google Gemini. Those are all foundation models. And then you're stacking on top of that foundation model fine-tuning. And you're leveraging that fine-tuning to align that set of answers with a more purpose-built set of information. Now, when we talk about the big foundation models that you and I are used to using, those are what's readily available today. But as we go forward into the future, we're going to see more and more deployment of the open models, of the downstream models that are less capable today when you compare them with the likes of GPT-4, but they are effective enough and that they can work in conjunction with these large, highly capable models to build out purpose-built solutions. In fact, one of the discussions I saw earlier this week was a post on X that talked about leveraging 10 examples, a prompt built out. So you're doing a 10-shot prompt, providing exactly the output examples that you want with Claude 3 Haiku. That's the small and really fast model of Claude, and getting quality results that would equal a 0-shot prompt on Claude 3 Opus. And so as we begin to scale out the number of ways that we're applying this technology, we won't want to use those large API-based foundation models across the board. So what NVIDIA has built here is a platform that serves anyone, anywhere, because you're able to take a Llama 2 model that's been open sourced and available for the world to consume. And now you're giving the fine-tuning capability to that. You're making it ubiquitous and democratized so that anyone can take that model and fine-tune it for a purpose-built situation. And you're able to plug in your prompts and get your results out of that. And then you're stacking on top of that all of the quality things that you need to do, making sure that you've got aligned responses, making sure that you've got your guardrails in place. And this is really the more likely situation. If we look at the paradigm of compute, take the PC era, for example. The PC era was getting commodity hardware, putting an operating system on top of it, and then you could do anything you wanted with that computer. If you could write a program and it was able to run on that desktop equipment, you were fine. You could run anything that you want. You weren't limited in what was run. And that's kind of where we are with the emerging behaviors around the foundation models. You'll be able to take a model that's commodity, that's open source, apply some specialized data to it, and get a more customized set of answers that are built around exactly your need. And they're providing services that makes it easier to consume this capability. Because at this point, NVIDIA benefits so long as the compute demand is there. And I think that, at least for the foreseeable future, the amount of demand for compute is only going to go up because of the applications of these capabilities.
Evaluate its performance against other examples. And so we are effectively an AI foundry. We will do for you and the industry on AI what TSMC does for us building chips. And so we go to TSMC with our big ideas. They manufacture it, and we take it with us. And so exactly the same thing here. AI foundry, and the three pillars are the NIMs, NeMo microservice, and DGX Cloud. we're announcing that NVIDIA AI Foundry is working with some of the world's great companies. SAP generates 87% of the world's global commerce. Basically, the world runs on SAP. We run on SAP. NVIDIA and SAP are building SAP Joule co-pilots using NVIDIA NeMo and DGX Cloud. ServiceNow, they run 85% of the world's Fortune 500 companies run their people and customer service operations on ServiceNow. And they're using NVIDIA AI Foundry to build ServiceNow Assist virtual assistants. Cohesity backs up the world's data. They're sitting on a gold mine of data. Hundreds of exabytes of data, over 10,000 companies. NVIDIA AI Foundry is working with them, helping them build their Gaia generative AI agent. Snowflake is a company that stores the world's digital warehouse in the cloud and serves over 3 billion queries a day for 10,000 enterprise customers. Snowflake is working with NVIDIA AI Foundry to build copilots with NVIDIA NeMo and NIMS. NetApp, nearly half of the files in the world are stored on-prem on NetApp. NVIDIA AI Foundry is helping them build chatbots and copilots like those vector databases and retrievers with NVIDIA NeMo and NIMS. And we have a great partnership with Dell. Everybody who is building these chatbots and generative AI, when you're ready to run it, you're going to need an AI factory. And nobody is better at building end-to-end systems of very large scale for the enterprise than Dell. And so anybody, any company, every company will need to build AI factories. And it turns out that Michael is here. He's happy to take your order. We need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn.
Okay, so let's go back to all of the partners since we covered that. Here's what I'm interested in. When you see the companies that NVIDIA is working with, they are working with the biggest players that have the largest share of their particular marketplace for enabling these capabilities. And this does two really important things for NVIDIA. One, it gets them closer to the problem that needs to be solved, but doing so at a scale that is on a global footprint. So when you have the likes of SAP, they are known the world over, right? You get the widest swath of customers by working with them. And the level of applicability there is really important. When you look at the capabilities of ServiceNow, there are so many companies that are using their portfolio of products. Then when you look at capabilities that Cohesity has in terms of backup, when you look at the companies that they are working with, they're capturing the lion's share of the capability from a generative AI portfolio, because NVIDIA understands not only the core compute and software needs, but what the problems are that are going to be solved are going to rely on a platform. So this play by NVIDIA isn't just, hey, we've got compute. This is, hey, we've got the entire platform. We're your partner of choice. Cutting out some of the other players, semiconductor and otherwise, that would traditionally have a part of the ecosystem. From an investor standpoint, this is probably the biggest opportunity that we could see for NVIDIA continuing to grow, because it's not simply based only on their hardware portfolio. They're actually building out a level of standardization that marries people to their platform, because they've created a unique set of capabilities that can be widely deployed.
And how to be a robot. We call that virtual world Omniverse. And the computer that runs Omniverse is called OVX. And OVX, the computer itself, is hosted in the Azure cloud.
The future of heavy industries starts as a digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins.
All right, so I have to stop and talk some more, because this is something I spent a great deal of time on over the last several years. In fact, the reason I've attended the GTC conference for the last 3 years running is because of their simulation and this concept of a digital twin. They've been perfecting the art of capturing an environment in multiple different ways and representing that in a simulated way. And this is really, really valuable and important. Think back to the comments that Jensen made early on in the keynote. He talked about this idea of how long it takes to do the compute necessary and how many floating point operations per second. If you took that and you did them in a serial fashion, that means you did them one after another, you would need a very long time to complete that. But if you can parallelize that operation, entirely new things are possible. And what we can do with these digital twins and models is accelerate by parallelization of a set of tasks. So now I can do 1,000 things at once, and it will take me less than 1,000 times less to complete that operation in simulation. You couple that with all of the calculation and the understanding of the world, you can build models that you can then run through and leverage for completing a calculation. This is some incredible capability. And at this point, I would say that they're very mature in their conceptualization and deployment of these concepts. The Omniverse now has been around for over a year. And one of the key things that I really like about the Omniverse is that it includes an element of physics to the simulation. So you're not only simulating the movement of things and observing how objects are fluid in a situation, but you're able to do that with real physics simulations as well.
Once you connect everything together, it's insane how much productivity you can get. And it's just really, really wonderful. All of a sudden, everybody's operating on the same ground truth. You don't have to exchange data and convert data, make mistakes. Everybody is working on the same ground truth. From the design department to the art department, the architecture department, all the way to the engineering and even the marketing department. Today, we're announcing that Omniverse Cloud streams to the Vision Pro. And it is very, very strange that you walk around virtual doors when I was getting out of that car. And everybody does it. It is really, really quite amazing. Vision Pro connected to Omniverse portals you into Omniverse. And because all of these CAD tools and all these different design tools are now integrated and connected to Omniverse, you can have this type of workflow. Really incredible.
This is NVIDIA Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation.
Okay, so let's stop and talk about this for a minute, because the things that they're doing with Groot are also really fascinating. And I think what we see happening here is they've built out the capability to train a model, and they're applying the use of that model that they've trained then to run the logic behind the robot. In fact, one of the biggest challenges that we've seen with robotics is that for so many years, we've had to write lines of code in order for a robot to function in the real world. When Tesla had their AI day over a year ago, they were sharing some of the details around their self-driving capabilities. And in that event, one of the engineers shared that they were able to replace a 500,000 lines of code program with an AI model. And what you're seeing here is that NVIDIA now has made that transformation possible for anyone that wants to do programming of a robot. When you couple the ability of running a model that's been trained with DGX on OVX to simulate it, Now you can have a robot understand the world and simulate that without there being any danger to the people that are involved, because you can simulate everything in an environment that does not have any humans because it's entirely virtual. So they built this entire ecosystem to simulate the real world for robotics development, and they've provided a foundation model that allows a robot to understand the world around it from a multimodal standpoint.
And OVX systems for simulation. The GR00T model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks. And emulate human movement just by observing us. All this incredible intelligence is powered by the new Jensen Thor robotics chips, designed for GR00T, built for the future. With Isaac Lab, Osmo, and GR00T, we're providing the building blocks for the next generation of AI-powered robotics.
Okay, so we have to talk about this Jetson processor. What we've seen here is now NVIDIA has provided the hardware for building models, the hardware for running models, the hardware and software for simulating the real world, and the processors necessary to be used in the robotics that consume all of that. Essentially, what you see is NVIDIA now is providing the entire stack necessary for a company to build and run a robotic setup in the real world. So what we're going to see as a direct result of what was announced at GTC is a robot explosion, because the limitations and the technology necessary to train, run, and manage those robotics products is now possible through what NVIDIA is providing. The question now is, will that be enough for companies to create reliable products that you and I will want to bring into our lives? Look at all the robots. I mean, these are things that are running today.
About the same size. The soul of NVIDIA, the intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment. The name of that project, General Robotics 003. I know, super good. Super good. Well, I think we have some special guests. Do we?
I'm going to talk over this because there's not a lot of conversation.
Hey guys.
What we see happening here is
So I
sort of a
understand you guys
collision
are powered by Jetson. They're powered by Jetsons, little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research. Come on, you guys, let's wrap up. Let's go. 5 things. Where are you going? I sit right here.
This is an ironic moment because I think this is also where we are with generative AI. Where are you going? What are you doing?
Come here, Green. Hurry up. What are you saying?
It turns out that
no, it's not time to eat.
Sometimes difficult to get computers and robots to do everything to do.
I'll give you a snack in a moment. Let me finish up real quick. Come on, Green, hurry up. Stop wasting time. This is what we announced to you today. This is Blackwell. This is the platform. Amazing, amazing processors, NVLink switches, networking systems, and the system design is a miracle. This is Blackwell. And this, to me,
So an incredible announcement, honestly, done by NVIDIA here. I think what's interesting about what they've released is it's a very comprehensive set of components that allow you to do something much more detailed, much more interesting with the capabilities that they're providing. And so it's no longer just a matter of what's available on the cloud. It's now a matter of what's available for you on your own system. In fact, a few weeks ago, I shared the release that NVIDIA came out with, which is called Chat with RTX, which allows me to use my NVIDIA GPU that's in my system for gaming and leverage the code that lets me run a foundation model and use retrieval augmented generation to find documents and information inside of all of the files that I already have. They're stacking these capabilities one by one to build out something that is much more detailed and much more interesting, actually. When we look at what's possible today, I think NVIDIA is looking ahead and they're thinking through, what are they going to really need? What's the next level of capabilities that are necessary to really take generative AI and make it largely available across so many different use cases, across different technologies, across multiple different visions. And so I was really impressed with what they shared. And I think it's a great story that is something that we're going to be paying closer attention to as we go forward in this new era of generative AI. And I want to close with a few thoughts about some of the things that I observed and learned through not only the keynote, but through the subsequent tracks and learning opportunities that came to me through NVIDIA GTC. I don't have the video to share with you today, but many of the sessions that were available are totally free for anyone to sign up, register with NVIDIA, and go take them. In fact, I believe you can go sign up and register for the platform today and go take any of the courses that are available. If you are looking for opportunities to become a bigger personality in AI, don't overlook NVIDIA, because I think these capabilities are going to be essential going forward. I don't think that NVIDIA has the AI corner on everything. Certainly, they have a major role to play, so you wouldn't be mistaken by looking into the offerings that they have available. But some of the conversations I saw this week demonstrated three really critical things to me. One, in a session, I saw and heard numbers from a company that talked about exactly how much dollars they are deriving in value from the use and deployment of generative AI. In another session, I learned about all of the different ways that NVIDIA is advancing the capabilities in running and optimizing the compute across the platform. So as we saw in the keynote, it's not just the raw hardware and how they've increased the functionality of the hardware, but also the ways that you are able to use it by leveraging different floating point levels and combining that with the advanced capability. We're taking the processing and expanding it in orders of magnitude rather than simply 1 or 2x the platform. And then the third is the larger visionary things that are happening in the background. It didn't come through very well in the keynote, but in one of the sessions that was hosted by Jensen, I was able to really see Jensen's passion about this idea of expanding compute. In fact, he tells the story in the keynote of NVIDIA's history, and that they were thinking about things not just from the standpoint of, oh, fancy, cool looking games, but a new paradigm in compute entirely. And I think that we are just now beginning to see the real vision. Jensen has opened up about how he sees the capability of parallel computing and this massive parallel capability that is the nature of accelerated compute. I think that there is probably a lot more that he's still not revealing, But there's a lot more to this paradigm of parallel compute. And we're going to see some subsequent announcements, I will predict, over the next 2 years. I expect they already have a roadmap that goes well beyond Blackwell and is a plan for expanding these capabilities on smaller and smaller platforms. We all understand in the infrastructure business that you have to not only provide the capability, but consistently make it more mobile, more deployable across the board. So this generation is really the cloud compute level. The next generation is going to be at the desktop level of compute, followed by the likes of laptops that have a much more constrained power requirement, which is very clearly understood by the folks at NVIDIA. They're thinking about not just the raw compute, but how much power it takes to run these things. And then inevitably to our smart devices, being able to run it on an iPhone and carry it around with you. We've already seen some leaps and bounds in terms of condensing information, compressing all of this knowledge into a few gigabytes. The world's knowledge that takes terabytes to represent and petabytes to represent, and putting it in smaller and smaller packages. And this is really exciting to me. And I think I was really impressed with the overall vision and the thoughts that are being brought to bear. NVIDIA's continued to grow and partner with the companies that are building the next generation of the world. There's some really great things to come, and I look forward to talking about all of these things with you. For those of you that are on, if you have any questions, I'll take those now. And if not, I hope you're enjoying what I'm sharing here. We've got so many interesting things to cover in the future. I've already got several videos planned ahead of time for things that have happened just in the last couple of weeks. Some really exciting opportunities in AI for those of us that understand it and for those of us that want to use it. So if you're enjoying what I'm doing here, give us a like, give me some comments. I'd love to hear from you. If there's something that you'd like to learn more about, I'd love to learn about that, and maybe we can discover more about it together and go make some AI mistakes. We'll see you next time.